Welcome to this video about forming the chain rule. So here, let's look at this expression. We have z. That's our outermost variable. Then we have x, and we have y. Those are our intermediate variables. The t and the t then is our independent variable. That's how you think about the structure. So follow my cursor, please. As you do that, you internalize the material better by focusing your mind like a laser beam. When you go down this branch, stop here, and you say the partial of z right here with respect to x. Notice this uses the partial derivative symbol right here and right here. The reason is that z depends on x and it depends on y. So down one of the branches, especially over here, it has to be a partial derivative. Then you reach x. So this is your first intermediate variable. Then you go down this other branch right here. So again, please pay attention like a laser beam. On the bottom, you have t. Now notice when you go down this branch where I'm tracing one more time, it says dx dt using their ordinary derivatives symbol right here. The little d looks like a normal d, but this backwards 6. So it's dx dt. Then you go down the other branch beginning from the top where I've just highlighted. So as you pay attention, you internalize details better, remember? So you're going to do the following. You go down this branch, you stop for a second, and you see here it's z, and it depends on y, but it is so partially. That's why here you need to have the partial derivative symbol here and the partial derivative symbol there, both places. Then you hit y, which is your intermediate variable on that side. Now y itself over here, if you follow this branch down to t, this y depends only on t. That's why here this is a regular d and a regular d. Those are regular derivative, ordinary derivative symbols. So here's the basic procedure after that. You multiply down the branches and add across the branches. So you get the following over here. Let me zoom in on this part, especially here. So notice it's z right here and t down below because we're differentiating with t ultimately. But this is the regular ordinary derivative d and regular ordinary derivative d, not partial, because ultimately the z here depends on a single variable t, So here's what we read through this. You're going to take the first derivative, which is the derivative of z with respect to x, partial 1. You're going to multiply by the ordinary derivative of x with respect to t. Then you add to it the partial derivative of z with respect to y, and you multiply by the ordinary derivative of y with respect to t. So then this whole expression right here, that defines the chain rule expression. Okay, so that's like a level 1 example, the simplest one, where this z here depends on x, which depends singly on t, and where the y also depends on the same t. Let's go down to another example down below. Yeah, let's look at this one. So let's see. This is a little bit different because you have z here depending on x and y. Those are our intermediate variables, the x and the y. But the s and the t and this s and the t, those are our independent variables. We can change their values as we like. And as that happens, we change x and y, which then gets fed into z. So let's go through this process. So let's go down this branch right here where I'm tracing. So as you, again, follow along, please be sure to focus your mind like a laser beam to support in mathematics. So you're going to have the following symbols right here. The partial of z with respect to x down this branch. Now, when you reach x, which is an intermediate variable here, you go down this branch to s. But notice the difference now is that x also depends partially on s. So you have partial derivative symbols here and here. The reason is that x, as you can see, depends both on s and it depends on t. So we're going to do the partial of z with respect to s. So what I'm saying here is this one right here. Right? We're doing the partial of z with respect to s. You see this? We're looking for that. Go back here a step. So you're going to multiply down these red branches here. But then you got to go over to the other side. And you have then the following. Let's read through this. So the partial of z with respect to y. Y is your intermediate variable on that side. Then you have the partial here with respect to s. So as you can see, there's an s over here and there's an s over here. So some people show s and t here twice, or you could do it once, but then the lines cross and it becomes messy. But it's the same variable. So what I mean is this s I've highlighted over here in yellow is the same as this s in yellow, which is then allows us to create our chain rule expression. So let's look at that step next. You multiply down the branches and you add across the branches. Keep that in mind. So let's break this expression down. So you have the partial of z with respect to s. So you take the partial of z with respect to x, you multiply by the partial of x with respect to s. Then you multiply the partial of z here with respect to y by the partial of y with respect to s. The difference here is in this expression, you have only partial derivatives because z depends on x and x depends on s. Z depends on y right here, but the y also depends on two separate variables, so only partial derivatives this time. Okay, so let's see. Let's do one last example. Okay, so here is the same expression. I remember x and y are intermediate variables, s and t are independent variables. Z is kind of like the dependent variable here. And we want to differentiate with respect to t now. So keep that in mind. So you want to form the derivative of z with respect to t. So mentally, you should be picturing now which set of symbols to write down for that in terms of z and t. Would that be a regular derivative, ordinary, or a partial derivative? Which set of symbols corresponds to that? Imagine, okay? As you imagine, you get better and better. All right, so let's see here. I'm going to go down this branch. So this is going to be the partial of z with respect to x, because z depends on two variables. This here is x. Now the x, as you can see, has its own two branches. So that's why over here is the derivative of x with respect to s. But now this time, we're going to use the derivative of x with respect to t. We're going down the red branch over here. Then we repeat on this side. Again, this is going to be z with respect to y, that derivative. And then that brings you to this here. But the y itself, as you can see, also depends on two variables. You go down this branch where y depends on t. So now you write a chain rule down for this step. How do you do it? Well, you have the partial derivative of z with respect to t. Partial symbol and partial symbol this time. Partial derivative of z with respect to x. Multiplied by the partial derivative of x with respect to t, all partial symbols, plus. So you multiply the derivatives down in branches and you add across the branches. Partial derivative of z with respect to y. Multiplying the partial derivative of y with respect to t. Like that. All the same as before. Partial derivatives here, only partial derivatives. Alright, that's it for this one. So I hope this has been helpful. Please be sure to subscribe, like, and then check out the other videos on this channel. My name is Tom. I'm a math instructor. I post videos on math like this. Sometimes I have them pre-typed. Sometimes I write them in real time. Sometimes I do more exploratory videos of mathematical concepts.